Slideshow 5. Okay, here we go. This is where we left off, slideshow 4. And you can tell he's getting his back into it. That's how come we're breaking these wrenches. See, you can grab a piece of flat bar and bend it, but that gives you more leverage and a rounded off, more comfortable handle. And it's all blurry because I jerked the camera. This is Boy. If we have 2 guys or 3 guys, sometimes Joe Mel does this some too. They'll have like sections of the work table. They just take turns over here, and they all work together. They work together really well. So there might be a see, making a bend. It's 2 or 3 seconds, and you're gone. And you go and put it back on the pattern. See if you need to bend it a little more, or extend the length of the bend, or whatever. So I don't know how many people could use one bending jig, but it's not a problem with 3. Okay, this is the new rebar shear. It's now got braces welded over here and over there. I mean, we didn't cut maybe 4,000 or 5,000 pieces of heavy flat bar with it. I don't know why it would act up. That flat bar's 1.5 inches by 0.206, and that's what they're cutting with it, is the flat bar. It takes all that handle. Aurora's looking like she knows how to use the thing. She knows where the handle is, but her feet would be off the floor and she'd be jumping up and down, and it wouldn't cut anything. You'd laugh at her. It takes me both hands to cut something with that, and I use the whole length of the handle. The guys use it about where she's grabbing it, and they weigh, I don't know, 90 pounds less than me, and they just sit there and cut one right after the other. I'm afraid it's going to fall over or something go wrong and I hurt myself, and they just grab hold of it and rip and tear. This is just out of the form work. This is our helical stairs. We only deal with flat forms, though we make some curved surfaces. So you had a piece here. We drew this up in CAD to see what the shape of the forms had to be. We never made a print. We just took some dimensions off of it. And we went and looked for the phenolic board that was damaged and cut out one fairly good piece. And we only had to use them one time. So we went through our pile of experienced phenolic board, and there's one on each side of this connected with 4 through bolts. The same thing on the inside, except they're really narrow. The stair treads were continuous formed. That's 3-inch hole saw. We have a 3.5 or 4, but I had played the devil to get the thing. I had to go to Decagon City to get it. I got a spare too, but I'm not going to send it clear up there to get some just because I use it on a bunch of stuff covered in concrete. So I got the biggest one that I can buy at Wilcon out of our set. I can replace it if I have to. Though I just sharpened it with an angle grinder and it cuts better than it did in the first place. But those 3 pieces let us tell how deep the cement was in the stair tread. We could take a little 9-inch piece of rebar and shake it around there. There's all kinds of rebar in these stairs. It's, I don't know how many pieces, 10 or 12 in that step. Plus you got rebars going across the treads that go through the concrete walls, sides out to the outside. They go across here, sitting on rebars that are the width of the local point of the tread, and then they go down, and then they bend down the angle of the staircase. So there's not a lot of space in there. You have to get all the air out. So these holes, the 3 holes, let you have air come out, let you shake a bar back and forth to work the concrete up into that corner. And then you can pour some out of a bucket up here and shove it in the hole and push it to the side until it starts showing up at the next hole. But basically you can fill that stair tread through those 3 holes. And we saved did this with a hole saw, so we saved these little round circles. And then we collected them back up from the kids 2 or 3 times until we were ready to pour, because they were a great toy. But I needed them back. So I got them back at least 3 times. And when I was done with this, I gave them to them. They wanted them, they didn't have them. But when we get it completely full, then we push those plugs back in the hole to make it flush. But they don't stay there. You see how this is sticking up 1/8 of an inch or 3/16? Same with that one. The hydrostatic head of the concrete here and us, doing our worst. See, we poured it from up at the top all the way down around to the bottom. I don't know how far that concrete had to slide down to get to the bottom tread. But you'll notice that we have a full tread. There's edges on everything. There's no honeycomb anywhere in the stairs. So, but they look fairly rough right here. But there's some videos posted before this video, like update of helical stairs, after they've got the first finish coat on them. And I was really surprised how well they came out. Also, the bottom of this is shaped. It's not just a smooth something coming around there, or like a shape of a step. It's got an odd made-up shape on it, just to give it some architectural flair, maybe. I'm not sure. And when we did the finish work, we put a groove around here to put our LED light strips. But these stairs were poured to have the LED light strips under the tread down here, and they're recessed back. There's a toe kick on each of these treads. They're only 2.5 inches thick up here, but the next 5 inches is a toe kick that goes back 3 inches, and there's a recess in the back of that, of the toe kick for the step. So you can walk up the stairs on this side because your foot can fit under the stairs. I mean, you can have 2 or 3 people wide walking up, coming down middle of the stairs and over, because your heel has to come down past the nosing on the tread, and your toes of your shoes hanging out here. So the shape going down is not ideal. If you walk down sort of at 45 degrees, yeah, you can come right down there. And we've also changed, we were going to put little pieces of 2-inch by quarter flat bar sticking up and weld pieces of pipe between them to make the handrail. We're going to roll the handrail around in our pipe roller out of stainless pipe, and then make some uprights to mount them with. And having them cut between the at every stair tread, that lets us rotate that next one 2 degrees so that it makes the helical shape rather than a round curve being sprung out of kilter trying to get it stuck to that. This is not a continuous curve of a constant radius. It's a radius with a twist. There's 270 degrees of twist from the bottom to the other end of that piece of pipe if it was a twist. So basically you have to roll it, turn it, twist it, roll it, twist it, roll the next, twist it, roll it, and you clock it as you go through your roller. And getting it back out of the roller is not so bad. If you roll it backwards, it'll come right out. But you have to mark that on your pipe. And if you get the amount of twist wrong, it's throwaway. There's no fixing it. You just adjust and make another one. I made a set of these for a place in Plymouth, North Carolina. It was a mill owned by Louisiana Pacific Lumber. They want some stairs like this, except the stairs were metal. The handrail took longer than the stairs. I built the stairs flat and then stood them up with the overhead shop cranes. They were 35 feet high, and they didn't want a landing in them. I went back and saw them because I said with the run and rise you take for, we were using the Coast Guard design limits for stairs, which is good for rain and water and stuff, more than the industrial code. So I use Coast Guard code on them. There's four codes for stairs. Now remember, what you do, they don't pay you because they point to a different code. they just know that if they do that, they won't have to pay you for the materials or the labor. So I got screwed on every set of stairs I ever made, except this one. This one for Louisiana Pacific. I sent them a bill and they paid it. Surprised me. And I walked up to my buddy and says, you know what? We just built our last set of circular stairs. He says, why? I says, we got paid for one. We'll never be as far ahead as we are today. All we can do is get farther behind. So no more helical stairs. I don't care how good of a customer they are. I don't care if we're trying to court them as a customer, a new customer. No more helical stairs. Cite any kind of reason you want, other than the fact that we're going to jack the price to cover what it actually costs us to build them, and you can have it or not. But I'm not wanting to get into that kind of business practice, so just tell them we don't do helical stairs. Tell them we don't know how to build them, because apparently we don't. We made 3 or 4 of those handrails, and as bad as that outside handrail was, the inside, we hadn't learned enough that we didn't have to make about 3 tries on this inside one as well. It's the same amount of twist in a lot less length, in a little over 40% of the length of that one for this one, but the same amount of twist per degree of rotation on the stairs. And we knew what the numbers were for the outside. Didn't do us a bit of good on the inside. Had to start from scratch. We got more bent up, destroyed pieces of pipe, and I made them out of heavy schedule pipe, so there was a lot of money thrown away there. And that's the only thing on that job we won the quote for. You know, all the equipment was built. We didn't win a piece of the contract other than those stairs. And we sent them a beautiful set of stairs. I mean, they'd look good in anybody's house. And they were absolutely perfect by Coast Guard building codes. And they paid the bill. So I did put a landing on them. I went back and talked to them. I says, I know you don't want a landing, but you showed me what you want the first tread pointed at, parallel to down here on the bottom, and you showed me where they wanted to come out at the top. When I do the right number of rises to get up there, the rotation is not right. It's pointing out more out into off the roof than it is towards the building, and we need about 5 feet more rotation at the top to make the landing end the same as the bottom end. I don't know if that makes sense on this video, but it made sense to the plant manager. He says, okay, then put a landing in it, just one. I said, all I need is one. In fact, it'd be more problematic to do 2. I says I could reduce the rise and bring them on around to right over top of the bottom one, which would work on both ends. Or I could put more rise to them and or change the run and rise ratio, but it won't be by code. To stay inside the code, I need to have a landing. That's the best solution. So he let me do it. Another guy only hired Mexicans. They're shorter than Filipinos by a bunch. I put the handrails on a whole building at 36 inches high, because I watched the guy walking up and down the first set of stair handrails I did. His head was below the top handrail. He was running his hand up the intermediate rail, and his head was lower than the top rail. If he'd have tripped, he'd have fell right between the 2 of them onto the ground. Wouldn't have been nothing to stop him. He'd been all, fingers and screaming on the way down, but he wouldn't have never grabbed anything. So I lowered it from 48 inches, which was code for those stairs, to 36. And I had a guy climb them, and he was smiling ear to ear, smiling in Spanish, but or Guatemalan or wherever he spoke. Never could figure out what language he was using. But he loved them. When it come time to pay the bill, they said they weren't going to pay for it because it wasn't 48 inch. I says, I'll tell you what, I'll come in Sunday when you're not running, and I'll bring 2 guys, and we'll raise them up to 48 inches, and we'll grind all the welds flush. You won't ever tell it was that way. And you want to change the height on the rest of the handrail in the building from one end to the other. Give me the height you want. I don't care what it is. You tell me, write it on a piece of paper, and we will change it, no charge. Tell them we're the Athlete's Foot Gang. We just keep coming back. He gave me the heights. We changed it. And Monday morning, I said, okay, now you realize I'm not going to charge you for the change, but I expect you to pay me the contract price for the stairs, the catwalks, the handrail, and the equipment that it's all hooked to. So he paid the bill, and he didn't say much, but he can tell I knew he was trying to get out of paying for that, by claiming it wasn't to his building code, which it was not. But it was safer for the employees. And what I did was I raised it all up, and then I put an intermediate rail, second intermediate rail at 36 inches. And there's no code on how many intermediate rails can be in a handrail. I checked with the lawyers before I did it. So it was safe for them. I felt better about it. He didn't get it for free, but he did pay his bill. Anyway, that's helical stairs. It's helical because it's not got a center axle, and the center is half the width of the stair tread. That's why we call them helical rather than spiral. Spiral has this, the treads run right to the axle, completely to it. And curved staircases, there is no center hole, and I'm not sure what how big this inner tread has to be before it becomes a circular staircase. I know it's more than this, though. I don't actually know what it is. It looks better blurred. This is the shape I was talking about. We made on the bottom just to give it a little flare. And this is the paint that come off of the forms, because it was some really old phenolic board. And all those holes were they're rebar. Most of them are rebar sticking out. They're under the stair treads, and a few of them are holes were, at least 6 of them are holes that were between this piece of phenolic board and the one on the inside that made the other half. This wall, all this is one continuous piece of concrete. The two sides and the treads, up, and the center wrap in there, it's poured continuous over about 4.5 hours of pouring. We took the mixture up on the top floor and brought all the bags of stuff up there. And about 10 o'clock that morning we started, and I don't know, 4 o'clock in the afternoon before it got done. I don't know why that looks small, but that's what's called our narrow door. It really is. It's the camera image. That door is really about this high. And this cutout out here is all round, and it's rounded on the ends, and it's got some jiggles and joggles in it. Anyway, helical stairs. There's no, we put render on these and then skim coat. And the render was a piece of 1/2-inch plastic pipe. The way he put it on there was he drilled holes in it and drilled holes right into the concrete and knocked 3-inch concrete nails into a 5.5 mm hole. And that one nail here and one at the other end and one to hold it up a couple places. And that smoothness of that pipe being wrapped around the top and bottom. And then he used a straight edge aluminum bar to strike it off. So he made a really slick curve around there. Did the same thing on the other side. These have not been used yet. We use them to sit on. This is supposed to be wrapped in galvanized metal. The side with the slats on it, that's experienced construction lumber. And this is actually new phenolic board when it was put on there. The galvanized round ends face into the spokes of the spider beam, and that makes a round fillet on the end of that window. And the reason for that is we got electrical conduit pipes that didn't come up inside of the spokes. We got them in the wrong place when we were still trying to talk using rectangular grid beams up there. My wife hated it. I may have hated it more. So we just invented the spider beam. And after we did that, then it made a difference where that electrical conduit came up, which did make a difference before. So some of it ended up on 2 spokes outside of the beam. And as a way to patch it, we're going to put these ends in with about 4 or 5 inches of concrete at the narrowest part, and then just pour that. People sleep up there between those 2 roofs because it's really windy and there's no mosquitoes fly that high. This is the guys. That's the 3 wise men. We got a Mary and a Joseph and a big donkey and a baby donkey and sheep, and that's for the nativity scene. We compromised. I'm not sure what I got in the compromise. I had some rebar sticking out up there. I was going to put some kind of decorative posts on. I was thinking Easter Island type tikis, I thought it would look really nice. She wasn't having it. She thought it was some kind of idols of some other religion, and she's definitely Catholic. She wasn't going to have it. And so she started talking, 10 of the 12 disciples. I says, well, you can leave out Judas, and who else are you going to pick? No comment. And I says, I don't want to live in a religious shrine. I'm not having it. We're going to have to either put nothing up there, just cut the bars off, or do something that we both can live with. And she said, well, can I have a grotto? I says, okay, you can have a grotto. And it turned out the grotto ended up life-size figures, and it's 25 feet by 30. It's bigger than some houses here. Anyway, this is some of the stuff that Oka, our painter, plasterer, artwork person, made for us. We kept him busy for several months on that. This guy needs a little more concrete on him. He's kind of thin. And this, what looks like a fencing helmet, that's going to be his face. But that's the first part of the armature. I'm not sure how much armature goes in because it gets wrapped with all this screen. And then it's sort of like Faro cement with the cement on both sides of the screen. I'm not sure what, I think it's I was going to call it a tang, but it may not be. You can see the size of the window compared to the size of the Filipina. So she's ½ inch over 5 feet. So this window is just under 5 feet. Maybe 3 inches under. This might be welded. That might be, of course, it's not clear enough in this picture. We had to take them across the street because we can't get the electric service in our house. Yeah, those are welded because this is the downstairs, the living area floor. This is the 10 outside windows. One goes between the master bath and master bedroom, and one between the kitchen and the living room. So if they're all rolled and stacked like that, they've come down one floor and got into one room. Those are welded. They need to go to the galvanizer, but lockdown, everything is closed. All the businesses are closed, and they'll be too rusty to galvanize next year. Here she is with some of the, quote, life-size wise men. Must have had bigger people back in the day because they're a foot taller than she is. Seems to me like the Holy Family lost out on this deal. They're the size of children. And that's the little sheep. She got biblical references for everything that's in this nativity scene. So there's nothing left out. This is render, just wherever the render ended up being flat. We'll take a grinder with a diamond wheel. We'll cut that back 1.5 inches from the edge of the window well, knock it out. And then we'll drive in 3-inch concrete nails and wrap tie wire all around between the nails. And then we'll fix that edge back to a sharp corner. And this is going to become a table in the house. This is the form for the large window. We also got one for the small window. It's going to be another table. But that goes from the master bedroom, which she's in, to the master bath. I cut the master bath off by 1/3, and that's our electrical room. That's the cow. We had to have a cow too. I don't know if that's incense or myrrh, but that's a wise man. That's how the edge of the render is. If you're going to trim it and fix it later, I told him I'd rather have the wall completely flat than have that corner fixed ahead of time. So all the time went into making the wall flat. And this is 1 cement to 3 sand, 3 sifted sand, white sand. This is looking through a window opening out towards what's going to be the water cistern someday. 37,500 gallon water system. I don't know if it's the camera doing that or it's really that way. It could be that wavy because that's where a window was, and it really didn't make any difference. We bought this and we use it for all kinds of stuff, from rolling windows across the street to where we have electric at the machine shop over there. Haul dirt, haul bags of cement. It's a self-dumping. If you start the handle over to dump and get it about 45 degrees, it'll go the rest of the way and dump. It's like a Dempsey dumpster. You can see how the legs rot off on these things. That's looking for a new patch. Got a patch up here already. Got an extra patch there. Got a patch there. Got a patch here. Got a patch there. And this is the better set. The other set really looks a mess. Pigeon coops. I don't know, maybe started out with 5 and pretty soon we had 28. They breed well in captivity. I think they breed according to the feed. Throw a coffee cup of feed in there and you'll have 1,000 of them. There's one that's in focus. This was the standard Filipina making a business out of absolutely everything. She was going to raise white doves, which pigeons are doves. Pigeon's a rock dove, but it's a dove. Same bird, different color feathers. She was going to make white wedding doves to release at weddings, like 3 to 8 in a wedding. She kind of thought that might be when they threw them up in the air at the wedding that they would home back to where they came from. They didn't. They just kept on going. But the mistake was she didn't eat the ones that weren't white or put them in a separate enclosure to keep them from breeding. So the white feathered pigeons got mixed up with the multicolored feathered pigeons. And you know how that ended up. No. Hit the wrong button. And updates are available. Sure they are. Another pigeon. They have a better water bowl than the dog. The dog's water bowl got carried away. We got water bowls for every dog, and people decided they were better for cooking with, and the dogs are going thirsty. This is the top half of a door form with a piece of something laying. I don't know what that is. Maybe it's tape. We put duct tape, that not D-U-C-K, not the metal foil tape that used for ducks, but the stuff people think is duct tape. Concrete, if you put oil on this, it doesn't stick to concrete. The metal tape, I don't care what you put on it, it becomes part of the concrete. It's absolutely the world's worst to get it off. This is it's a window form. Okay, the orange one is in the wall yet. So that's the big one. This is the small one. And this is that one we just looked at. That's the half top of the door. And you can see how much shoring lumber is under holding this concrete floor up that was poured. Above this went some sleepers across the top and phenolic board, and then another step of these went up to hold the weight of the spider beam and the concrete for that. So this is not overkill. There's an awful lot of concrete, and plus we couldn't make these all one height. They'd be too much buckling. So we put the floor up there. These are the same forms that were used for the living quarters floor of the house. That's just the height they come out. And instead of having one block to keep them out of the water down here, we put a block and a board that took up a difference in the phenolic board that we were using for the to form up the floor, so it was the right height. And also, you knock out that block and these things fall away from the ceiling, and you just carry them away. You don't have to beat it apart. It comes right apart. Take the screws out and walk away with it. This video is long enough and dinner's here, so we're going to try to stop it. And if you liked the video, give us a thumbs up. Didn't, thumbs down. You have a nice day. Bye.